This is geometry. This is the semester 1 exam review. This is unit 2. We're talking about rigid transformations. Rigid, remember, is when the sides and the angles don't change their shape when you're transforming it around the graph. We slide it, it's called a translation. We flip it, that's called a reflection. We rotate it. Many different transformations. So we're going to use this rule here, which is x minus 8 and y plus 4. So we're going to start with our shape, which is, what is the image of 2, 6? That's point A. So we have to figure out where A prime is located. We're going to do this translation to it. That means that we subtract 8. That means we go to the left 8. And that would be up 4 more. Where would that be? Well, if A is at 2, 6, and we're going to do this rule to it, A prime is going to be 2 minus 8 and 6 plus 4. So A prime is going to be at negative 6, 10. What is the pre-image? That means where does it start? If we're going to land at negative 3, negative 10, which is way down here somewhere, where do we start? One way to think about it is to take the rule x minus 8, that equals negative 3, and we'll add 8 to it. And we'll take the y plus 4 and subtract the 4. So we must have started at 5, negative 14, if we were to go left 8 and up 4 to get to this location. So C would be at 5 comma negative 14. It's a lot easier to count if we can graph it on the grid, count it on the grid, but if it falls off the grid, it's a bit of a challenge. The vertices of triangle PQR. So we have our R, Q, and the P. So I'm just going to get rid of this A altogether. Apparently this grid wasn't used for that question. Now we're going to graph and label the pre-image. That's what we did here. And we're going to figure out where the image is if we apply this rule. This is a lot easier to apply to. We're going to go negative 1, positive 3, negative 1, positive 3, negative 1, positive 3. So this becomes Q prime, R prime, and P prime. List the coordinates. Well, P prime is going to be 1 to the left and 3 up. Q prime is going to be 1 to the left and 3 up. And R prime will be 1 to the left and 3 up. This next one we have triangle ABC, which is our pre-image, or the original. A prime, B prime, and C prime. Let's see, this is red funny here. A prime, B prime, and C prime typically would be your image. They're saying that the A prime, B prime, and C prime is the pre-image. It's before it. It's the pre-image of ABC after a translation. Write the rule. Even though this says pre-image, reading the sentence, it would make sense if it said triangle A prime, B prime, C prime is the image of triangle ABC after a translation. What is the translation that made this A prime, B prime, C prime? So look from A over to B. You had to go to the left 1, left 2, left 3, left 4, left 5. We had to go to the left 5. So what we're going to say is our x is going to minus 5. And from that minus 5, we have to go up 1, 2, 3 more. So that would be the rule, and you could test it on all of your points. We went over 1, 2, 3, 4, 5, and up 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. On the next side, we're going to reflect each figure over the given line. The line is called y equals 1. So we're supposed to reflect over the line y equals 1. So we need to be sure that when working with y equals 1, it crosses the y-axis. Every one of these coordinates is up 1. That's why it's called y equals 1. The x's all change to get up to there, but the y's are all at 1. So to reflect it, we're going to count the perpendicular lengths that it takes to get even with that line of reflection. So we come down 1 to get even with it and 1 to get past it. That would be A prime. D prime, 2 to get even with it, 2 to get past it. 2 to get even, 2 to get past. So then we can connect those together. Then I often like to shade it in. It just kind of highlights it a little bit better. So here we need to reflect it over the line y equals negative x. So negative x is going to go this way. Okay, so when we reflect it over the line y equals negative x, we have to count, in this case, this is a negative slope, so we got to count positive slopes to be perpendicular to it. So we look at the diagonal. The diagonal is 1 away from it, so we got to go 1 past it. 2 diagonal, so we got to go 2 past it. Here we'd have C prime and D prime. They're not going to move at all. So there's our new shape. We're supposed to reflect this one over the line y equals x. So when we do that, we're 1 1/2, so a half and 1. 1 to get even with it, 1 to get past it. 3 to get even with it, 3 diagonals to get past it. Since the slope is 1, we have to go at a negative 1 slope to be perpendicular to the line of reflection. So we'd have C prime, A prime, and B prime would be up here. Now we have to describe what rotation that we have going on here. If you notice, this doesn't look like a slide where you would come over and up. This looks like it's a turn. C is on the right, and when you turn it once, it's now on the up. So if you noticed, by placing the pen down on pencil, down at the origin, I can rotate the paper one time, and now my figure is right where the other one was. Here's the line, x equals 1. Well, there's the line, x equals 1. So it looks like a 90 degrees counterclockwise. Typically, all the measurements are done in counterclockwise. So sometimes you don't even call it counterclockwise, but I think it's good to get used to labeling that. Now, there's a rule for your points also. This would be good to remember for the test. We call it, a lot of times we use the letters A and B instead of X and Y, especially for rotations. But the rule is going to be to switch the A and the B is going to be a rotation, and because we want it to fall to the left, we want it to rotate to the left, we're going to put our negative on the left side. Look here, we have our 90, or we have the A, and it's pointing to the left, and now we want to make it point the A prime pointing down. Notice that we have a horizontal line here, and we have a vertical line there. It looks like it's going to be another 90-degree rotation. "90 degrees clockwise." Well, that's actually counterclockwise still. Sorry, it's still to the left. What we just did. It's a rotation. And the rule, which you should be familiar with, is negative BA. Now notice this one. Currently, we're horizontal. And if we rotate it 90 degrees clockwise, then we're going to go straight up and down. The C is going to be at -1, -2. Well, -1, -2 is exactly where we wanted it to be. Typically, we don't rotate clockwise like I've mentioned. We typically go counterclockwise. So that's rotating to the right. So how many times am I going to need to rotate this shape to get the A to be pointing straight up? Okay. There's 90 degrees. "90 degrees again. So that's 180 total. 270 degrees got the A to be pointing straight up, just like the dotted picture was. So by rotating our picture, we can see that this is a 270 degrees counterclockwise. So that rule is going to be BA, because we're switching the A and the B, and we put a negative on the right. The way that I remember that is because a 90 degrees to the right would put the A right where we want it, pointing upwards, the top of the screen. because what we're trying to match up with also has an A pointing to the top of the screen. Last one for Unit 2. How many lines of symmetry does this figure have? Lines of symmetry are where can you fold the paper so that the graph lies exactly on top of each other. If we take this paper and we fold it, we could fold it right through the center here, and this side would fold right on top of that one. We could do it up and down also. So there's definitely two lines of symmetry. But if you're careful, you could also rotate it sideways. I'm sorry, have our lines of symmetry sideways. If you folded this sideways, the vertices would all match up. And you could also fold the paper or the figure that way. So 1, 2, 3, 4. 4 lines of symmetry.